My name is Renellys Perez. I'm an oceanographer in the United States at NOAA's Atlantic Oceanographic and Meteorological Laboratory. Today I'll be sharing a little bit about the South Atlantic Meridional Overturning Circulation Basin-wide Array, or SAMBA. SAMBA is an international MORD array involving researchers from Argentina, Brazil, France, South Africa, and the United States, focused on observing the strength of the overturning circulation at the entrance to the South Atlantic, nominally along 34.5 degrees south. The full list of co-authors for this presentation is listed here with their affiliations. SAMBA is part of the larger South Atlantic Meridional Overturning Circulation, or SAMOC, program. The SAMOC initiative began in 2007 with the goal of measuring the strength and variability of AMOC-related transports in the South Atlantic and interocean exchanges. Some of the countries are listed on the slide. There's the MORD SAMBA array that I already mentioned along 34.5 south. GEOMAR has a TRACOS array, which consists of a mixture of tall moorings and bottom pressure recorders, deployed in 2013 along 11 south. SAGA was deployed by Spain and Mexico in 2021. AMOC-related transports are also measured at multiple latitudes in the South Atlantic from repeat XBT transects, CTD transects, and in situ XBT and Argo and altimetry syntheses. I didn't include all of the lines, but we're doing this along many lines in the South Atlantic. There are also sustained CTD and XBT lines in the Drake Passage and south of South Africa. The SAMOC Executive Committee involves scientists from South America, North America, Europe, and Africa, and their names are listed on the slide. The South Atlantic Ocean is special because it's the only basin with equatorward heat transport. It's also a gateway for waters formed in all of the other oceans to exchange, mix, and ultimately reach the North Atlantic. Waters are also formed in the South Atlantic. And lastly, idealized and theoretical models suggest that the overturning circulation, or AMOC, can be either monostable, and that means it would be slowly varying, or bistable. If it's bistable, it can have an on state and an off state. And if AMOC shut down, that would have a huge impact on society. Most of the few observations we have of freshwater transport in the South Atlantic suggest that we're in a bistable regime. SAMBA's observational capabilities have changed over time. SAMBA started off in 2008-2009 with 4 United States NOAA pressure-equipped inverted echo sounders, or PIs, on the western boundary, and 2 French CPIs on the eastern boundary along 34.5 south. When we have temperature and salinity data collected from cruises while servicing these moorings, the information from the moorings and that temperature and salinity data can be used to estimate the northward and southward flow across the array on the boundaries. In 2012, Brazil added more CPIs instruments on the western boundary, and South Africa added tall moorings on the eastern boundary, and France added more CPIs on the eastern boundary. More recently, Brazil added interior moorings in 2019, and South Africa and France continued to deploy PIs and CPIs on the eastern boundary. As an example of our partnerships on the western boundary, or SAMBA West, the U.S. maintains 4 PIs sites on the western boundary since 2009. Brazil and Argentina conduct annual hydrographic cruises to service the array and collect hydrographic or temperature and salinity measurements. Argentina is planning to deploy 2 tall moorings on the western boundary in 2022. Brazil maintains multiple PI sites and moorings on the western boundary and in the interior, and we're planning to have several cruises in 2022 to recover and redeploy the moorings and extend our hydrographic data sets. As mentioned earlier, Spain and Mexico conducted a cruise in March-April 2021 to deploy tall moorings and PIs along the nominal longitude of 10 west. The southernmost PIs was loaned to them from the SAMBA East team and provides another data point in the ocean interior on the eastern side of the Mid-Atlantic Ridge, and it also links SAGA with SAMBA. This slide is showing the locations of the tall moorings that will be deployed in the west in late 2022 by the I-Atlantic and Tri-Atlas projects. These projects involve collaboration between Argentina and the EU. I won't show all of the results from the SAMBA array, but just give you a quick example. We took the better part of the instrumented record during the years 2013 to 2017 and used 9 of the SAMBA moorings to generate a better estimate of the volume transport by the overturning circulation. In previous years, we had less moorings And by adding more offshore instruments, we were able to capture some of the deeper flow variations. Specifically, we can simultaneously estimate the volume transport in the underlying abyssal cell at the same time as we're estimating the transport in the upper AMOC cell. In this 2020 study by Marion, we found a mean upper cell transport of 17.3 sverdrups northward. 1 sverdrup, if you're not familiar with that unit, is 1 million cubic meters per second of flow. The lower cell transport was 7.8 sverdrups southward. And you can see the daily time series in the slide of those two concurrent transports. Both the upper circulation and the lower abyssal circulation are very energetic. We found that both of these cells vary largely independently of one another, and both contribute to the total heat transport across 34.5 south, although the upper cell does dominate. This is the first time that we resolve both components of these flows in the South Atlantic, and it is only possible through the international SAMBA coordination. We are creating new data products in the South Atlantic that can be used for numerical model evaluation. This is really important as these models do predict a reduction in the strength of the MOC, and the more observations that we have to constrain these models, the better. Just like the other AMOC arrays, SAMBA data is being used to study variability on the boundaries. SAMBA west moorings and hydrographic data have been used to study the Brazil current, deep western boundary current, abyssal flows, as well as detect long-term warming trends in the deep and abyssal ocean. SAMBA east pies and tall moorings have been used to study variations of eastern boundary currents, including the Benguela current and the deep eastern boundary current. To conclude, the SAMBA SAMOC observational community has made exciting progress. We have a lot of observations, and we're learning just how variable the overturning circulation is on short time and space scales. The larger science community is starting to use these observations and numerical models to study mechanisms controlling the overturning circulation and boundary current variability. We want our observations to inform improvements to models, and as the records become longer and more available to the public, their use will only increase. Thank you to the Argentina, Brazil, France, South Africa, and United States partners and funding sources without whom we could not do our SAMBA fieldwork, and to the larger SAMOC community for their support of our efforts. A lot of work goes into going into the field to maintain the arrays and collect and process the data, and we thank the people that routinely do so. Thank you so much for listening to my presentation.